Hi, almost done. Two more. Conditional probability on this page, then independence on on the next page and next video. So, conditional probability, you might remember, it's determining a probability given you know some conditional information before determining that new probability. So, as an example, I think this is a pretty good question. What's the probability? Well, let's get this guy. What's the probability that you'll go to the next home Rose-Hulman basketball game? And in your mind now, you probably have an idea what that is. But if I turn around and gave you a condition, I wonder if this would change. So, what's the probability you're going to go to the next Rose-Hulman basketball game given they're raffling off 10 full ride scholarships? So if that condition changed your probability, well, first of all, there's dependence on the two events if it changed it. If that information didn't change your probability, then we would say that's independent. Those two events are independent for you. But for the most part, at least now you know what a condition means. I tell you some condition, it may or may not change the likelihood of you of the probability of that event, but it's still a condition. If it changes the probability of that event, we say those two events are dependent, and if it doesn't, we say independent. But first, I'm kind of getting ahead of myself. I should give you the definition. So notation, we say that's the probability of A given B. So the probability of A occurring given that I know B has already happened. And B then is the condition. The way we define this is probability A given B is the probability that both A and B happen given you know B has happened. So it's just a ratio of A happening in combination with B given B has occurred. So in picture, I think this is pretty nice. Probability A given B, once I know B has occurred, I know I'm sitting in this part of the sample space of S. B has occurred and I'm right there. Now the only way A is going to occur now is if it's in that little intersection. So if I get my pen here, A is going to occur right here. So A given B is just really a ratio of the intersection of A and B divided by the probability that B occurs. So here's an example, a nice one with just rolling a die. Roll a six-sided die and record the up face, or just record what occurs. Let the sample space S be the outcomes, and let A be the event of getting a 2, B be the event of getting an even. So S is just 1 through 6. A is the event of getting a 2, and B is the event of getting a 2, 4, or 6. 4 or 6. So what's the probability of A? That's 1/6 if I have a fair side six-sided die, and B is 1/2. Now let's find some conditionals. So what's the probability of A given B? That's the probability A occurs given that we know B has already occurred. So in English, what's the probability that we're going to get a 2 given I know that an even was rolled? So given I know that an even was rolled, I know I'm sitting in this sample space now. The only way A can occur is one out of those three. So it's the probability of A given B here is 1/3. And notice that changed. Probability A was 1/6, but knowing B has occurred changes it to 1/3. So we'd actually say the events A and B here are dependent. Knowing one changes the probability of the other one occurring. Probability of B given A, this is a little bit tricky, but what's the probability that we're going to get an even given that we know a 2 was rolled? So given that we know a 2 was rolled, we know for sure B has occurred. So actually probability B given A is 1 in this case. I have another couple examples before I do independence. Here's page 9. Here are claims to a insurance office. Out of 100 claims, some of them were fire and fraudulent, some were auto. So here's how all the 100 claims break up. I'm going to use this notation: FR for fraudulent, F for fire, A for auto. What's the probability that you're randomly choosing a claim out of this bin and you get a fraudulent claim? So fraudulent, there's 10 fraudulent claims out of 100, so 0.10. But now, what's the probability that it's fraudulent given you knew it was fire? So if it's fire, I know I'm sitting here. fire, that's my new sample space, is 20, and fraudulent given fire is 6 out of the 20 that occurred. Next, suppose that you know that a claim is non-fraudulent. Non-fraudulent means I'm sitting here and I know there's 90 of them there. So 90 is my basement. What's the probability? It's auto. So auto is right here. Auto given non-fraudulent is 29 out of 90. Wow, I feel like I should just take care of independence while I'm here. It's probably too long. So there's conditioning, and I'll come back with one more, which is independence.